Now, there is a little trick with detection accuracy. It's called the base rate fallacy. And it's called the fallacy because it's one of those little mind puzzles that is a little bit contradictory to people when they first hear it. So I'll try to explain it using these scenarios. And it has to do with the fact that the rate of attacks on your system also affects what type of detector you'll choose. So in other words, how common are attacks on your system? The answer to that affects what detectors you would want. So to see why this is true, let's consider a detector with a 0.1% false positive rate. So that's very good. This means that for every 1,000 non-attacks, only one of them will be mistakenly alerted as an attack. So 1,000 users access your system. One of them gets accidentally flagged as an attacker when they were not. Let's take this system, which seems pretty good, and use it on our website. Let's say our website receives 1,000 non-attacks and 5 attacks per day. And let's assume that we catch all 5 attacks, so the false negative rate is 0. Well, in that case, out of the 1,000 non-attacks, one of them gets accidentally flagged as an attack, and all 5 of the attacks get flagged. That's pretty good. That means that as the operator, you see 5 attacks and 1 false positive, and you have to deal with those. That's not bad. Seems like you found all the attacks, and there was 1 false positive to deal with. Not so bad. Now, let's say your server gets really popular. You've blown up, and tons of users want to use your system. So now, instead of just 1,000 legitimate users, you now have 10 million legitimate users. You're a very popular website. And they're still the same 5 attackers from before. Now, if we run the exact same system, the same false positive rate 0.1% system, let's see how many false positives we get. There are 10 million users. 0.1% of those users get accidentally flagged as attackers. This comes out to 10,000 false positives. So now as the operator, every night when you go and see what the detector says, instead of seeing 5 attacks and 1 false positive, which you have to sort out, you now see 10,005 alerts. It's a big list, 10,005 alerts. 5 of them are real attacks. 10,000 of them are false positives. As the operator, now you are faced with a pretty hard task. You have a list of 10,005 attacks to look through, or potential attacks, but 10,000 of them are total bogus and they're false positives, and only 5 of them were actually attacks to begin with. That could be pretty expensive. So this is a little bit counterintuitive. We use the same detector in both cases. It's not like the detector got better or worse. This 0.1% stayed the same. The 0% false negative rate stayed the same. So the detector didn't change. The only thing that changed was where we were using it. And so one reason why this is kind of counterintuitive is the fact that the same detector used in different contexts can yield good results or terrible results. You could get 6 alerts, and most of them are attacks, or you could get 10,005 alerts, most of which are total bogus. That's one interesting observation. A second interesting observation here is that in the second case, when you get that list of 10,005 alerts, the vast majority of them are not attacks. So this is where the base rate fallacy comes from. When you pose this problem to average people and go out on the streets and you pose this problem to them and you say, you've received a list of 10,005 possible attacks. How many of these attacks are really attacks? And most users will say, well, probably most of them, right? Because the detector found 10,005 things to investigate. But in fact, the vast majority of the 10,005 alerts are total false positives. That's the thing that's pretty counterintuitive. Even though this false positive rate is so low, it's 0.1%, in that 10,005 list of alerts, well over 99% of them are totally false positives. And that always confuses people. They see this number. They cannot believe that 99% of alerts are false positives. But if you do the math, it is true. 99% or more of these alerts are false positives. That's another reason why people call this a fallacy. People always get this wrong when asked on the street. Now, one final takeaway from this whole kind of fallacy section is that detection is really hard if the base rate of attacks is low. What we mean by that is if you have a system where there are just so few attacks, like 5 out of 10 million and 5 in total, that rate of attacks is so low that accurately picking out those 5 is extremely difficult. Even a 0.1% false positive rate means you scoop up tons of false positives. So it's kind of like that needle in a haystack problem. You have a big haystack, and there's one needle that you have to pick out. Even if you go in and scoop up the needle, you're probably scooping up tons of false positive pieces of hay in addition to the one needle that you're looking for. So if the real attack is very uncommon, and it's one needle in a stack of 10 million and 5 hay pieces, then even if you go in and very accurately scoop up the right part of the stack, you're probably still scooping up tens of thousands of false positives that you then have to go through. So detecting it accurately is hard if the base rate is low. OK, here's the base rate fallacy in text. I forgot I had this. So you can see that there was a list of 10,005. 5 are real attacks, 10,000 are false positives. So the probability that one of these is an attack is actually 0.05%. That is a really low number that most people don't come up with. That's the fallacy that we referred to earlier.